Hi guys, let's have a quick read of this question. So it goes here, the diagram shows a small block B of 3 kg and a particle P of mass 0.8 kg, which are attached to each ends of a light inextensible string. The string is taut and passes over a smooth pulley. There's a smooth pulley. B is held at rest on the horizontal surface. Okay. And P lies on a smooth inclined at 30 degrees to the horizontal. When B is released, when B is released from rest, it accelerates at 0.2 meters per second towards the pulley. Okay, right. Let's have a quick go at this then. So, just to go to double check. Here the diagram is very mass particle which is attached by electric spring. The string is tilt, passive smooth weight. Okay, B is held at rest, and P lies in the smooth incline. Okay, so what we got here, B is released from rest. So the question says, by considering the motion of P, show that the tension in the string is 3.76. Okay, let's have a quick look at this. So what we got here, we've got the weight coming down on here, which is 3g. We've got the weight coming down here of this, which is going to be 0.8g. And if we went and draw this with the right angle here, the force that's coming down with that. Now, if that's coming down here, okay, that's being dragged back by this tension, and that's going to be, because it's the same string, by that tension being pulled that way. Okay, and don't forget that's 30. So coming down, we can work that out later when we go to these kind of things. Now here, I know you don't need this, that's got a reaction here of Rn, and that will have a reaction, I'm going to call it Rp if we need it. Probably need that for the second part. So let's just have a look at this so far. What have we got? We just need to know what is the forces coming down here. Now the force coming down here, because that's 30, that's the opposite. So that will be hypotenuse, which is 0.8 g sine 30, and that's coming down. Okay, so what we got, so if that's coming down, I'll just write it here. So these are coming down the slope. That's like literally the weight on the slope coming down, 0.8 g sine 30. And what's stopping it from falling at that is the force going opposing that, which is the tension minus T. Okay, and that's going to equal the weight of that, which is going to be 0.8 times acceleration. Now that's just Newton's second law. Okay, so that's just telling you resultant force is going to equal mass times acceleration. Okay, so if we got that, what else do we know? Let's have a look. So we've got that. Now it tells you, show that that is that. Okay, have we been told anything else? Yes, we have. We've been told that when B is released, it accelerates at 0.2. So we've been told that A is equal to 0.2. So we've got that. We know that what is, so we can work out the tension. Therefore, if we rearrange this, take that to this side and take that from there, T will equal 0.8 g sine 30 is the same as a half, and then minus 0.8 times acceleration is 0.2. Okay, I'll literally put the T on that side and I'll subtract that from the other. So what do we have? If we put this in our calculator, we should get that. I'm just going to quickly do the math. So on your calculator, when you put this through, you're going to get T equals 94 over 25, and if you press the standard to decimal SD button, you'll get 3.76 newtons as required. So we've done that first part. Happy days. So that's I done. Second part, calculate the coefficient of friction between B and the horizontal surface. Well, that's smooth, so there's no friction there. So the only friction we're going to get is here. So first of all, when we find friction, friction is equal to friction is less than equal to mu times the contact force. However, because this is starts accelerating and it's in motion, that implies friction is at its maximum. In this case, it will be mu times R, and I'm going to call RB because that is the reaction from here, RB. Okay, so that's what's RB on here. And in this case, RB, because there's nothing else acting on there, I'm just going to put RB is equal to 3G. Okay, so we got everything that we need. So friction when it's at its maximum is going to be mu times 3G. Okay, and what we got here is we got this tension, which we've already worked out. That's pulling that, so it's going to be tension is pulling that. What's opposing it is friction. Okay, and that is moving. First of all, that's going to be Newton's second law. That's going to give me the resultant force, and that's going to give me mass times acceleration. Mass in this case is 3 times A. Now, because they are connected, that A is going to be the same as that. And let's put all our numbers in now. So tension we know is 3.76. Friction we said is going to be mu multiplied by 3G, which is going to equal 3, and we know that the acceleration, because they are connected, they're going to be move at the same pace. It's going to be 0.7. So let's rearrange that, put that to this side, put the rest on there, so we get mu times 3G equals 3.76, subtract 3 times 0.2 is just going to be 0.6. okay, and then we're going to get, once we subtract that and divide it through, mu would equal that, subtract 0.6 is going to give me 3.16 all over 3G. Now G is 9.8. If we put that through your calculator, you're going to get 0.107 to three single figures. Okay, hope that helps. So you got to get the resultant force coming down from here. No, don't know what's happened here. Let's go back. Come down. Right. So you got to get the resultant force coming down in both cases. So hope that helps. Thank you.